Hello, my favorite algebra class in the entire world. Today I am gone, and I know you're all very sad about that. But today we are going to be continuing without me. We're going to start today talking about Chapter 6, Section 5. And so today things are going to be a little crazy because we're no longer just talking about lines. We are going to be talking about linear inequalities. So throw back to the beginning of the year, we talked about inequalities, which, remember, they have little alligator mouths, that whole thing. And now we're actually going to be turning those inequalities pretty much into lines, but because they're inequalities, remember that there are lots of possibilities for solutions when we have inequalities. So when we're solving linear inequalities, same thing with our linear systems. We're pretty much taking an inequality. Eventually we're taking a couple inequalities, and we need to show, where the solutions are for the problem on a graph. So to start us off, the first kind of things that you're going to be seeing today, this is probably going to be like the most basic piece that we're going to be looking at, is kind of questions that they'll ask in the beginning is they'll say, they'll give you an ordered pair, and they'll say, is the ordered pair, so remember an ordered pair just being like a coordinate, so some sort of xy value. So is the ordered pair a solution of the inequality? So again, these are going to be the most basic questions that they ask because obviously things get more difficult. And so this, first we're going to be looking at if the ordered pair is a solution. Sorry, shaky. Okay. So all we do for these problems is, if you're trying to figure out something is a solution, all you do is you plug in the values. So we plug in the given x and y values to see if the statement is true. So in this case, remember it's an inequality. So if you plug in some numbers and you get like 10 is greater than 5, like that would make the statement true, okay? So we're going to be looking for, again, if we plug things in and the statement is true. So let's take a look here. So we're going to tell if the ordered pair is a solution. So this will be our first practice problem. So for our first one, let's say they give you the coordinates 7, 3. And let's say they give you the inequality y is less than x minus 1. Now really quickly before we actually solve this one thing to note is that with linear inequalities, so not just inequalities, remember inequalities we would just have like x is greater than 10. With linear inequalities, you'll notice that we have the x and the y, and that's what makes them linear, is having both of those. And so that's when we'll actually be able to kind of build lines with this information, but more of that later. So for now, what we're going to do is we're going to tell if the ordered pair is a solution. So we have 7, 3, we have our inequality. Pretty basic, we just plug in our values. So we have an x value and we have a y value. So where I see a y, I'm replacing with 3. So 3 less than, my x is 7, 7 minus 1. I get 3 less than 6. Is 3 less than 6? Yes. So it is a solution. And that's all I'm doing for my answer. So I've shown my work, and all I'm just answering is yes, it is a solution. Okay? So again, all I've done there is I plugged it in, and I finished up, and you'll notice like I didn't try to get everything on one side. You don't need to do that. All I'm just finding is I get 3 is less than 6. I ask myself, is that true? Yes, and therefore it would be a solution. Okay, let's try another one. Let's do 4, 5. Inequality would be y is greater than 3x plus 2. Now, let's play the game when I'm gone and I call on you randomly, even though I'm not there. And let's see how well I can read all of your minds. So, who would like to raise their hands and tell me my first step? Trey. Trey is always the first one to raise his hand, so I'm just going to assume he's raising his hand. Trey, tell me what I do first. Oh, good, Trey, nice. I label my x and y, and you're right, I'm going to plug in my 4 and 5 into my inequality. So I'm going to get 5 is greater than 3 times 4 plus 2, 5 greater than 12 plus 2, 5 greater than 14? Who would like to raise their hand and tell me what my final answer is? Alex, go ahead. Yes, Alex, you are correct. No, it is not a solution. Not a solution. Because, and want to tell us why, Alex? Yes, because 5 is not greater than 14. Excellent. Look at all of us. All right, so that was fun and easy, and of course, things get more difficult. So I know that you all, for the moment, really missed graphing, and so don't worry. We're going to start graphing now, so everything will be okay. So what's going to be happening now is we're going to start graphing the solutions of these linear inequalities. So just kind of keeping in mind the linear inequalities. So remember, it's an inequality, so it's not just a line. And we're going to be seeing our little alligator mouths, and we're going to see an x and a y value. So for whenever we're graphing these linear inequalities, the thing that I would just make sure everyone's keeping in mind is that with inequalities, remember, there are lots of solutions. So if x is greater than 10, x can be 100, x can be 1,000, x can be 11. So like there's so many more solutions, it's not just a line anymore. And we'll see why. So when we're graphing solutions of linear inequalities, we actually kind of want to do sort of like the same thing in the sense that we're actually still going to be using the slope and y-intercept. So we are actually going to be kind of graphing a line, and we still use the slope and y-intercept. So remember that if we have something in y equals mx plus b, we're able to have our slope and y-intercept. So we're actually going to be still using those things. The thing that's different about a linear inequality is kind of a lot, but if in the inequality they have little alligator mouths that don't have the equal sign, your line that you're actually going to draw will be a dotted line. So instead of doing a line like we normally do with graphing, you're actually going to do a dotted line if your inequality just has the alligator mouths that don't have the equal sign. But if you have the alligator mouths that do have the equal sign, that's going to be a solid line. So the kind of lines that we normally do, you'll have a solid line. Okay, so those are the basics about the graph, but the other biggest difference is that with linear inequalities, we actually do some shading, and I'm going to talk about that in a moment. So the first thing that we're going to do when we're graphing inequalities is we're going to, same thing that we do with our normal linear equations, is we're going to isolate y, okay, because we want it to be in y equals mx plus b, so then we can get our slope and our y-intercept. Now, these will not be y equals mx plus b because there's no equal sign, it's an inequality, but you want y to just be on one side. So then what we're going to do is we're going to use the slope and y-intercept, and we're going to graph the line, making sure that you note if it's dotted or solid. Okay, so that's going to be a big, just tiny detail that you're going to want to make sure that you definitely pay attention to. So let's just do these first two steps, and then we'll go through the next step. So I know I don't have a lot of room, but so looking up here, I have a lovely graph, okay? And let's say I give you an equation. I'm going to give you the equation down here. Let's say I have y is greater than 2x minus 1, and I ask you to graph that, okay? My first step was to isolate the y. My y is already isolated. So now I need to identify what my slope and y-intercept are. I know it doesn't say y equals mx plus b, but the little alligator mouths for now, just kind of think of it similar to that in the sense that if y is alone, I can still get a slope and a y-intercept. Who would like to raise their hands and tell me what the slope and the y-intercept would be? Remy, go ahead. Yes, my slope would be 2, and my y-intercept would be -1. Perfect. So I'm going to go up here, and I'm going to go ahead, ooh, that was kind of messy, and I'm going to set up my axes. So I have my x and y axes set up. Now before you go ahead and draw a line, okay, All I'm going to do is do my y-intercept of -1, and I'm not going to connect any points here. I'm going to do my slope of 2. It's a positive slope. The slope of 2 is 2 over 1, so I'm going to rise 2 over 1, rise 2 over 1, down 2 over 1, down 2 over 1, okay? I am not connecting these dots yet, okay? So when I look at this inequality, I need to decide if my line is going to be dotted or solid. So taking a look at my inequality and taking a look at what we had said before, would anyone like to tell me if my line would be dotted or solid? Sunny, yes, go ahead. You are right, it is going to be dotted. So because I have just a sign, like just a greater than sign, so it doesn't have the equal, I would make this a dotted line. So when I'm connecting my dots, I'm just connecting them pretty much with my dashes, okay? And I still need to make sure I do arrows at the ends, okay? But I just have a dotted line. It is clearly dotted. Do not go through and do a solid line and then like tell me that it's dotted or something. Make sure it is very clearly a dotted or dashed line, okay? Now here's the fun part. I'm not done graphing. So the next thing about an inequality is the fact that, remember, there are so many possible solutions for an inequality. I need to show that in my graph somehow. So what we do to show that is we're going to test a point. So we're going to test a point on either side of the graph. And I'm going to tell you why we're going to do this. So we're going to test a point. So just like we did in our first practice for this section, we tested a point. It either made sense or it didn't make sense. So if the point that you test works, what we're actually going to be doing is we're going to be shading that side. Okay. And if the point that you test, if it does not work, sorry, I'm running out of room. You're going to shade the other side. Great. Very exciting. See my exclamation marks and everything. So if I'm going to take a look at this graph, okay, my next step is telling me, so first of all, I've isolated my y, did my slope, my y-intercept, I plotted points, identified if it's dotted or solid. And so now what I want to do is I need to pick a point and I need to test it. So you can test any point on either side. I am not testing a point on the line. It has to be on one side of the graph or the other. So if I'm going to pick a point, yes, could you pick anything out here? Absolutely. Anything down here? Totally. But let's not make life hard on ourselves, okay? I often, unless the line goes through it, I'm usually going to pick the origin 0, 0, okay? So I know we don't have a lot of room, but we could sort of do this in our heads, but I hate when we do that. So let's say I test the point 0, 0, okay? I have my x value, my y value. So if I plug those into my original inequality, I would have 0 is greater than 2 times 0 minus 1. I'd have 0 is greater than -1. Is 0 greater than -1? Yes. So the side that that point is on, what I'm going to do is I'm actually going to shade this entire side. Now, it doesn't matter how you shade it. Well, whatever. I usually do like lines kind of going away, if that makes sense. And you'll see why later. But so point is, we are shading this side of the line because I tested a point, it made sense. Now, the reason I'm shading is this is showing me that any point in this region could be a solution of my inequality. So like if I plugged in -1, 1, okay, that would be 1 is greater than -2 minus 1, so it would have been 1 is greater than, what, -3? So is 1 greater than -3? Yes. So any point that I take over here, if I plugged it in, it would make sense. So by me shading this area, I'm showing that everything over here could be a solution to the problem. Questions? Not that I can answer them. Wonderful. Oh, I know this is annoying, but we actually have to go to another one. We have 2 more practices. It's all for good fun. So in these problems, we're just going to do a couple more practice, and they're just telling us to graph the solution, okay? We're not going to be writing a lot. I just wanted to give us more room, so you're welcome. So, but it's actually solutions because we have lots of solutions to inequalities. So we're going to go ahead and graph the solution. So let's say I have y is less than 3x plus 4. Who would like to tell me what my slope and y-intercept are? Brandon, of course. Go ahead. Perfect. Brandon said my slope is 3, and Brandon said my y-intercept is 4. Who would like to tell me if my line will be dotted or solid? Sarah. Yes, you are right. I'm going to have a dotted line because I have the less than sign. Wonderful. All right, so taking a look at our graph over here, I'm going to set up the axes just so you all know I'm setting up a normal y-axis just for the purpose of this graph. I'm going to shift my x-axis down a little bit just because I know it's going to be better if we have that space up there. So on your own right now, take a moment and you can go ahead, plot your y-intercept, plot more points using your slope, set up your line, and then if you want to go ahead and test a point, you can, but we'll also do that all together. So, oh, look at us all wonderfully working. Beautiful. As you are working, you can go ahead and just check your work with me as well. So wonderful. And remember, we have a dotted line. So at this point, you should at least have the line that I have up here. So you can take a moment and check your answer. And then, though, we still have the second part where I need to test a point. Would anyone like to suggest a point to test? Sean, go ahead. Oh, Sean suggested 0, 0 because we don't want to make our life hard on ourselves. So 0, 0. Let's come over here and we're going to test 0, 0. So if I plug this x value and this y value back in, I'm going to get 0 is less than 3 times 0 plus 4. I'm going to get 0 is less than 4. Is 0 less than 4? Yes. And so if I know that this point is a solution, who can tell me what that means I'm going to do? Brianna. Oh, you are right. I'm going to shade this side. Now, we don't need to all be, shading. Like, the shading is not, we don't need it to be like a perfect artistic shade. It's okay. You can just do lines like me. I would say maybe not spend all our time shading beautifully, but try to do it so it's clear, but efficiently as well. All right, the fun does not stop. So we are going to do one more, and I know you'll be so excited about this. So last one, I'm going to, even though I'm not there, give you all time to do this one on your own. So we're going to have the same directions, graph the solutions, okay? And let's have our inequality 3x plus 2y is greater than or equal to 6. So, well, before you all start on your own, who can tell me there's one thing about this inequality that I need to change? Would anyone like to tell me what that thing is? Anyone I haven't heard from, because I'm sure people are raising their hands who I have heard from. Let's see, who else would be raising their hand right now? Oh, Miles, go ahead. Miles is correct. I need to still isolate my y. So Miles, talk us through my first step for isolating y. You are right. I'm going to subtract 3x from both sides. So I'll get 2y is greater than or equal to negative 3x plus 6. Then what, Miles? Yes, you are right. I'm dividing everything by 2. If I divide everything by 2, I've isolated y. So y is going to be greater than or equal to negative 3 halves x plus 3. Beautiful. Who would like to identify my slope, my y-intercept, and the line, dotted or solid? What else would we call? Would be raising their hands. Fine, let's just go with Trey again. Trey, you're going to explain this very efficiently, though. When you tell me my slope and y-intercept. Good, my slope is negative 3 over 2, and my y-intercept is 3, and is it going to be dotted or solid? Solid. Wonderful. All right, people, on your own, go ahead and graph. And I'll just sit here and talk to myself, because as you can all imagine, it's awkward to sit here with an empty classroom and try to teach imaginary people something. Okay, well, I'm going to go ahead and graph, and I guess even though I didn't tell you this before, I'm personally going to shift my y-axis and x-axis a little bit. Not the end of the world if you did not. Blah, 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 blah. Okay. So I have a y-intercept of 3. 1, 2, 3. Now, tricky is that my slope is negative. So remember that means my line needs to be going in a negative direction. Remember so that I can create the letter N with the line. So if I have negative 3 over 2, rise 3 over 2 in the negative direction, 3, 2 in the negative direction, 3, 2. Okay? Remember, if I connect those, it'll create the angle of an N for negative. Okay? Now this is exciting. I have a solid line. So that means I can just do a line like I normally do, making sure I have my arrows at the end, of course, to make it perfect. Now, even though this is a nice pretty line, because it's an inequality, I am not finished yet. So who wants to talk me through my next steps? I can't decide who I want to call on because so many people are raising their hands. What? Jesse, you want to participate? Please go ahead. So smart. You're going to test 0, 0. That's wonderful. I'm testing 0, 0. It's a point on one side of the graph. Let's go ahead and you can, by the way, when you're testing it, you can test it using this inequality or you can even use the original. So it doesn't matter, they're the same thing. So you can use that or you can use this. I'm just going to use the original for kicks. So 3 times 0 plus 2 times 0 greater than or equal to 6. 3 times 0 is 0, 0. So I get 0 is greater than or equal to 6. Is that true? No. So that means if 0, 0 did not work, that means I need to shade the other side. So shade, 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 shade. Oh, I could probably do better than that. Great. Any questions? Not that I can answer them. Great. So your sub today, Ms. Sanderson, is going to go ahead and put up the classwork. So you will be in your lovely perfect classwork groups, and you will be lovely and perfect. And once you are done, I know it's exciting, we have another section to do today. Yay! Did I stop the recording? Nope.